Good morning, children. We had stopped with a question that if the ocean was filled with any other liquid instead of water, how would it affect the aquatic life in colder countries? Right? This is where we had ended. Now we are going to discuss this question now. Now, if the ocean was filled with any other liquid instead of water, what would happen? That means, how is water beneficial for this aquatic life in colder countries? One major benefit of water is that it has dissolved oxygen and life can survive. Now that is for all aquatic life. But here the question is on specifically colder countries. Now in colder countries what happens? The water of the ocean freezes, right? When the temperature goes very low, water freezes. Now, when you know that when water freezes, it expands. Okay, its volume increases. Okay. So now in that situation, it becomes less dense. The density of water decreases when the temperature goes down. Okay. So what happens that the upper layer of the lakes or the seas, they freeze, whereas in the lower layer, water is present in liquid state. Okay, and that is termed as anomalous expansion of water. Now, because of this, what happens? Though the upper layer of the ocean or the sea is frozen, but still in the lower layer, water is there and aquatic life can still survive. Okay, now let's move. So now we begin with the topic expansion and contraction. Okay, what is expansion? This is a process that happens when materials get heated up. When we heat a particular material or it gets heated up naturally by the heat of the atmosphere, then the particles or the molecules of that particular material, they move away from each other and the space between them increases. This process is termed as expansion. Whereas the same molecules, when they are cooled, then what happens? They again come closer to each other and the space between them decreases. This results in contraction. You can see this feature in the first picture there, where in the first picture or the first half of the picture, the molecules are close together. But probably when they are heated, in the second half you can see that the molecules have moved apart. This the movement of molecules away from each other leads to expansion of the material. And again, just the opposite, when these molecules come back to their original place, then they come closer to each other and it is termed as contraction. Below in the experiment there you can see there is a tube filled with air and a balloon is attached to it. It's placed in warm water. So because of the heat of that warm water, air expands and the balloon inflates. And the same tube when placed in cold water, the balloon will again deflate. And the reason is because the bowl is filled with cold water and air also cools up and molecules come closer to each other. Okay. Now we have many applications to this principle of expansion and contraction. This is something which is very common, you must have seen, but we just discuss. The first one showing here is a mercury thermometer. You have seen that your mother uses a mercury thermometer when you are not well, right? When you have fever. What happens? She puts this bulb of mercury in your mouth, okay? And with the heat of your inner body, the mercury expands. As it expands, moves up the capillary tube and it shows the temperature. Okay? So that is the principle that's used in a mercury thermometer. Second figure here shows the railway tracks. You can see there, tracks are not a single track that is laid. So they are smaller pieces which are joined together and they are joined by fish plates. So here this picture shows one fish plate or one joint where you can see that space is left between the two tracks and then the fish plate is used to join it. Why is the space left? The reason is same again, because in the summer season when the temperature is very high during the noon time, So these metal, the tracks are made up of metals, right? It's made up of iron. So it expands. Now, if the space is not left, then due to expansion, it's going to crumple. Okay. So to avoid this crumpling, this space is left between the railway tracks. The next figure that you see is of the rim of a wheel of a bullock cart, right? When this rim is attached to the wheel, if the size of the rim and of the wheel is the same, then what is going to happen? Again, due to heat, the rim will expand and suddenly it's going to move out of the wheel. Okay, because when it expands, it becomes bigger than the wheel, and so it will simply move out. But here, when it is actually placed, what the blacksmith does is they uses a ring which is smaller than the wheel, little smaller, and then he heats up that ring. When he heats it up, it becomes the size of the wheel, and then it is fixed. After some time, when it again cools, then it has a proper grip on the wheel. Okay, so now even if it expands, it's going to be of the size of the wheel only, so it will not come out of the wheel. Okay, so that is the main principle. Now let's see some other examples. Here we have another example of riveting. Now what is riveting? You see here there are two plates taken, plate 1 and plate 2, and it has to be joined. Okay. For joining, this small red color structure that you see is called a rivet. Okay. So this is made red hot. Why it is shown red? Because it is heated and made red hot. So when it is heated, it expands again. Okay. And then in this situation, it is placed between the plates, and then from the other side, hammering is done. Okay, to fix it properly. And then after some time, when it cools down, it holds the two plates very tightly. So this is termed as riveting. Here also, the principle of expansion and contraction is used. Now the next example here is something which is very common, which we have seen at home also. Okay, this is the method that we use to open the cap of a glass jar when it becomes very tight. It's not opening. So what we do is we place it in warm water. So automatically the metal cover will expand and it becomes easy for us to open it. The third figure here again is showing the overhead cables. This also is a very common sight when you travel long distances along the highway. Then you can see these overhead cables, so many of them sagging, right? So during summer season, generally they sag. Why? Because the temperature is high and the wire expands. So since it expands, the length becomes more and it sags. Again, when winter comes, the wire is of the normal size. This is again another application of contraction and expansion. So now we begin with common causes of physical and chemical changes. The first point here is when we mix two or more substances. Okay, it could be either a physical change or a chemical change, depending upon what we are mixing. Like in the first figure you see, we mix sugar to water. So the end result is sweet water. Okay, it's a sugar solution. There is nothing new that has been formed. You get the taste of sugar also and of water also. And we can easily separate these two, isn't it? So they have not lost their identity. This is a physical change. In the same place, suppose we use two different chemicals which react with each other. So then the third substance that is formed will be a totally new substance. So then it becomes a chemical change. Now for heating or cooling, when we take an ice cream and remove it from the refrigerator, so what happens? It starts melting because of the heat from the atmosphere. And the same melted ice cream, once you keep it in the refrigerator, again it goes back to ice. Okay, but the same thing doesn't happen with, suppose, an egg. You boil an egg, Okay, so when you heat that water and you boil egg in it, what happens? It becomes solidified and a totally new substance is formed, because earlier it was in a liquid state, jelly like state, and then later on it becomes tougher. Okay, but when you cool it, it doesn't go back to the original state, showing that what has been formed is a totally new substance and it cannot be reversed back. Here is another cause, that is the effect of moist air. When moist air affects any metal, then again there is a new substance that is formed. Here in this case you find iron. When iron comes in contact with moist air, the presence of oxygen and moisture together help in the formation of an iron oxide, which you have seen earlier as rust. It's again a totally new chemical substance that is formed, because of which it is termed as a chemical change. Now with this, we come to the end of the chapter and we'll just check with a few questions. The first one is, a burning candle gradually becomes shorter. Is it a physical change? Give reason. Then we have, heating a substance can bring about a physical change. Do you agree with it? Give reasons for that. And Ria accidentally poured sunflower oil into a jar of water. Can she reverse this change? Three questions have to be answered by you. Right? Read the text properly, go through the video, and see what all you have understood and what you haven't. If there is any doubt again, you can get back to me in the next class. Okay? And then we'll be discussing the textual questions. Thank you, children.